So the leaf sap analysis is, for me, the plant is a mirror of the soil microbiology, of the soil chemistry. What I find there is like a blood sample of the plant itself. Photosynthesis is really the motor of the regeneration. And with the leaf sap analysis, I have a tool for my crops. The leaves, they can take up nutrients. And those nutrients can be quite complex, like an enzyme, a vitamin, an amino acid. And that's what we bring into liquid form directly onto the plant. So it's more precise, it's very fast, and we have the immediate effect.
Hi Adrian, how are you doing today?
Yeah, thanks Raphael. I'm very fine and I'm looking forward to talk with you.
For a little bit of context, maybe you could tell us where we are today?
We are right now in Halterhus. It's a farm in Switzerland, in the canton of Lucerne, and we are kind of in the hills just before the Alps starts, a bit on 750 meters. It's a farm with 18 hectares and has cows, crops, and some fruit trees and hazelnut trees.
It's a bit of a rainy day today, so we decided to record inside and be comfortable, right?
Exactly, yeah. Switzerland. I mean, I'm very lucky and blessed to have every year a lot of rain. I think it's easier to farm in an environment where you have the rain than all the time struggle with looking for the water, yeah.
Okay, yeah, I bet. And maybe you could tell us a little bit about your personal journey and what led you to become so interested and so passionate about regenerative farming.
I grew up on this farm. My father was keeping the farm, and first I learned to become an electrician, but already there I was working for a farming company, and we installed pig feeding system, so it was farming related, hard to technical things. And after that I started to travel. I also was in Australia on a dairy farm. I did milking and learned English there. But actually, I never fully had the passion in the farming. Farming was for me all the time too much with machines and be inside around animals. The milking was like 2.5 hours a day, and the pig feeding and taking care, cleaning the building was all the time inside. And somehow I never had the connection with nature, biology and farming so much. So I decided to maybe work more in developing aid. I saw the environment is essential for a quality good life. So the poor people, if they have at least the possibility to grow their own vegetables, to grow some fish, some chickens by themselves, they have at least the basics they need to have a decent life. But when I started my studies, then as an environmental engineer, I realized more and more we in the western part of the world have the same amount of problems. Our soils are depleted, our biodiversity is fading away. So I more and more got the desire to change something here than go to the other side of the world and tell how things should be. And that's how my desire started again to take over my family farm and try to do the transition here to a system where I can produce food and in the same time promote biodiversity.
So initially when you took over the farm, the family farm here, it was mostly producing milk and it was pigs, right?
Yes, exactly.
But you completely changed that.
Yeah, I still have cows, but I have now suckler cows, or in German Mutterkühe. And the principle there is to not produce milk. We produce just the meat. I had the buildings. I have a lot of grass land, which is too steep for making crops. And all in all, into an organic system, the cow suits well because I also get valuable fertilizer of it. So I just changed not the animal, but the product I produce with it, from milk to meat. I also transit to be organic certified, and I planted the hazelnut orchard because I want to bring more valuable products onto the farm. And I stopped having the pigs because it was for me a bit the wrong thing to import a lot of food from somewhere out in Europe or even soybeans from Brazil. It doesn't make so much sense for me. I think animals have to be fed from their own farm or at least from the same region. So I stopped there, but it also helped me to have more space in the buildings and have a bit time for other projects.
So today, actually, we're not going to focus too much discussion on the farming operation that you got here, but you're also very much involved in the science, the soil microbiology side of things, and a bit of, what you call it, engineering.
Yeah, exactly. But I didn't mention yet, yes, I not only have the farm. During my studies, I started a startup called EdaPro. It's a company which is focusing on producing compost tea and all the equipment to it. So this is also a big part of my work. I can very well combine the farm and the work with EdaPro, which is also farming related. I can use my infrastructure on the farm. I have, as a small farm, the time to do there some more things. And also when I have a lot of work on the fields, my customers have a lot of work on the fields and they keep me in peace. And as soon it's rainy, I'm sitting in the office, I get a lot of calls. So it really suits well to
combine both.
To combine both, yeah.
Right. So I really want to talk about this topic of compost tea, of brewing microbes and all of that, because we hear a lot on the podcast that it's a tool that farmers use, but we never had the opportunity to really dig deeper into the conversation and the science behind it. So maybe you could first tell us how your journey in sort of doing compost tea started and why.
My journey started during my studies. A good friend of mine in the studies wanted to find a solution how he can treat his pot plants in the flat without any external fertilizer. So he had a lot of green clippings from the vegetable, from cooking and everything, and he had his vermicomposter, and he used his vermicompost then to produce the compost tea and spray all his plants in the garden and in the flat. So his flat was more like being a jungle than a living room. And his plants grew very well. So we decided to do more further research on this YouTube do-it-yourself idea he picked up during his studies. And that's how everything started to roll out. And we had one project, it was not fully farming related, it was a golf course. They had problem with their putting greens that the grass got sick. And they looked for organic solutions, and we got there the opportunity to do a trial, and it was very successful. The treatment with the compost tea on this grass had a very good effect, that everything started to roll, that the university supported us to start our own startup company.
What is compost tea exactly? Why do we make compost tea? What's the process of doing that? And why not just use compost, basically?
Yeah, compost tea has a bit of funny name. At the beginning, we thought we should change this name because to sell a farmer compost tea is kind of hard, and the investors of the banks even laughed more about this idea. But it really tells you the core principle: you dissolve compost in the water. And this already brings us to the advantage compared to the normal compost. Just the use case on the golf course is you cannot spread compost on the golf pitching places because then the ball has a labyrinth to go. So the liquid version is much easier to apply. And there is also not so much highly quality compost around. So composting plants, they recycle organic material, and for this they get the money. But they don't get the money to produce a very microbial, diverse, very mature compost, which has this high diversity of microbiology. And to produce this highly quality compost, you already end up with a much higher price that you cannot really spread it in those huge amounts every year onto your fields. And when we have it liquid, we can apply it 3 to 5 times a year onto the fields on like highly cash crops, you can apply a bit more, on the pastures a bit less. You're very flexible when you do it, and you don't need a big amount of the compost, which lowers the cost, lowers the logistics, and the plant also has a better benefit of having it liquid, because the leaves, they can take up nutrients, and those nutrients can be quite complex, like an enzyme, a vitamin, an amino acid, and that's what we bring into liquid form directly onto the plant. So it's more precise, it's very fast, and we have the immediate effect. While with compost, you have to wait until the rain slowly washes in the microbiology. But of course, it's not fully the same. Compost brings much more nutrients. So compost is a better or basic fertilizers. And compost tea doesn't replace the compost, because compost tea doesn't bring so many nutrients. It's much more a biostimulant.
Okay, so it's like the difference between a fertilizer and a biostimulant. One brings the nutrient to the plants, to the soil, and the other one is more about stimulating the microbiology.
Exactly, yes.
Okay, so just maybe a silly question, but once you've done your compost tea, you've separated the liquid, right? That has all of the microbiology there. What do you do with the leftovers? Do you still apply that to the fields? There's still nutrients there, I'm guessing.
1,000 liter of compost tea needs 30 liter of compost. And after I sieve out, the leftover, when everything is dissolved, is maybe 2 liters of a kind of a muddy liquid. And this, in my case, I just add to the cow manure pit I have on the side in the farm, and like this all the time inoculate this manure pit with useful biology. Some other farmers take it and put it to the garden of the wife, to the vegetables, and I hear often then the wife suddenly starts to support the farmer much more, that he sprays in the evening compost tea, because she knows she gets this very good leftover, that her vegetables grow much better.
That's a nice one. But typically, how would one make compost tea? What is the process of making it?
The basics is you need a bucket or a big drum where you can fill in water. You need an air pump, and you need compost. And for the compost tea process, it often takes about 24 hours to 48 hours to produce the compost tea. There are also different recipes where you just sometimes steer or just make an extract within 3 hours. There is not one rule you can follow. It's a do-it-yourself idea which is done all over the world. So you find any way of solutions. We, as EdaPro, kind of standardize it to 24 hours, 3% of compost, and 0.3% of a food which is used to propagate the microorganisms.
Okay, because this is something I've heard before, is that there's sometimes an issue with certain compost being very efficient, others not so much. There's no standardized system, and so it's kind of hard to know how efficient your compost tea actually is. But in your case, you've sort of you've taken it a step further and made it into a bit more of a science, right?
Exactly. During our studies, we had 6 little brewers, and for 2 years we just tested what is happening during those 24 hours. A few times we kind of stayed awake 24 hours and constantly did the microscoping. We had all the measurement tools from the university, measured pH, EC, electrical conductivity, and so on, and get all this data. And then with this data and the comparison of all the studies, we get a quite high microbial density. We saw under the microscope we have the diversity, and the tea with the best recipe, and all the time was with the dissolved oxygen in the right levels. We took it to the next stage, to the greenhouse trials, where we narrowed all the recipes to 3 recipes and tested again on the plants to get all the data. And then we ended up with 1 recipe, 1 compost mixture, and the setup of the size of the compost tea brewer, the power of the air blower, and so on. And what we also realized, we really liked the system with a vortex, which is a complete other topic. I think we should talk later about it, about the quality of water and the structure of water. Yeah.
Yeah, for sure. Yeah. So I'm trying to understand, what were the variables that you were using to test all of these different recipes?
The variables are the design of the compost tea brewer, how much water to the power of the air blower, how much compost you add, which compost you add, and the food mixture. So you end up with many variabilities. And of course, I would say there are dozens other recipes out in the world which function well as good as ours. But in the end, you have to find your recipe, and we are very happy what we designed then, because since 12 years we work with the same setup.
Okay, yeah. and you did all of these different trials, different recipes. What were you measuring to sort of analyze to see what was working better than other? What were the...
First, we just applied to the plant and just observed everything. And we checked what is happening. Are the plants getting bigger, produce bigger leaves, produce more chlorophyll, have bigger stems, or just are healthier, have no disease, and so on. And each time what we also saw is we have higher root biomass. And at the beginning I was like, does it help the farmers when you have more roots? They want more yield. So we were a bit, yeah, okay. And in the case of the golf course, more root biomass was very good, because apparently the grass is then much healthier and the ball of the golfer is faster. So it's a better green. And this helps us a lot, because we get immediately a big first customer. And with it, we started also to test the system on other plants, because basically compost tea can be used for all plants which are growing in the soil. Mm-hmm. And like this, we have customers in tree care in the cities, tree nurseries. We have vegetable farms, apple farms, fruit farms, all farming croplands and green pastures and so on.
So you ended up with this one recipe, but is it possible, is it the case that this one recipe will work really well in one context, and then another one would work better in a different context, depending on what you're growing, what the soil conditions are, the climate and all of these things? Or is it...
I would say yes, but already to explain the system to the farmer, how to use the compost tea, how to produce the compost tea and so on, is quite difficult. It needs a lot of time, and to have the more and more different recipes for different purpose and everything would make it more complex. But I think in the future it would be a goal to start to differentiate more and find also other recipes.
I'm trying to understand how this actually works. I visualize my tea bag that I put in hot water and how it dissolves into the hot water. What happens when you do that with compost exactly? Is it just the microbes, they kind of detach from the physical material and just fall into the water? What's the process?
Yeah, exactly. The microbes, I tell it sometimes on my microscoping courses, they are like building up huge cities, which is the humus. And they are living in this humus. They have shelter there, they have the water, they have the food, so they are living in this humus. And that they leave it to the water, they need some nutrients, they like the air, they like the warm water, and then they slowly dissolve, also with the power of the circulation and the airflow. But this process, we saw, takes around 3 hours that really everything gets dissolved. And it's then not only the microbiology, also different humic acids, and also in a compost. Compost is very rich as well in those secondary metabolites, everything what the microorganisms produced. Also different enzymes, vitamins, amino acids. They're already also there in the compost and dissolve into the water.
So sorry, could you explain what a secondary metabolite is?
It's everything what kind of the microorganisms poop. Everything what they digest goes out into the water. And those are the different secondary metabolites.
Okay, so those microbes and fungi, they have processes like eating, ingesting, pooping, and all of that. And the kind of secondary materials, elements that are created from that life of the microbes is what you call the secondary metabolites, right?
Yeah.
Okay, sorry, go on.
So we have those compounds. So it is the biology which makes the effect in the compost tea. But in the end, when we use it on the plant, it's really those chemical compounds and not anymore the life. Each time we spray compost tea onto the soil or onto the plant, I prefer to spray it onto the leaves. We apply biology, but most of them gonna die because the environment is already set. There are already microorganisms and they are there because they suit to this environment. And we bring soil microbiology in a high diversity, but maybe they are not adapted to this environment they are getting. So there is only a little chance that some things get placed to this new environment, but we really saw the effect that we have a biostimulation which comes from those secondary metabolites. We feed the plant enzymes, vitamins, amino acids directly over the leaf or maybe also with irrigation over the roots. And this gives the plant like a bit of energy push. The plant can produce a little bit more photosynthesis, more sugars, and those sugars, they pump down to the root system and feed the biology which is there.
Okay.
Because the root biology is shaping the microbiome quite a lot. As soon as a seed starts to grow, around it, the microbiology changes to what was in the soil.
Okay, I had no idea. So basically, you're not necessarily just adding those microbes because you want to add them to the ecosystem and to boost the whole microbiome in the soil and on your plants. It's more like these secondary metabolites created by these microbes are like some kind of food for the existing microbiology that already exists on the plant, on the leaves, on the roots, and so on.
Exactly. Yeah, I think some biology gonna end up there, and we can raise the diversity. And if some players were missing, it definitely helps. But it's really about this bringing the connection back for the plant and the soil. It really, around the roots, we often see that the roots connect with the soil, and we see that when we dig out plants which were treated with compost tea, around the roots we have this nice rhizoheat. It's fine soil which is sticking onto the roots. So with this, I see the plant put again more food in form of some carbohydrates, some sugars, some root exudates into the soil, fed the biology around these roots, and around there you really see the humus formation and this very crumbly, nice soil sticking onto the root. And that's the effect which is happening a lot with composting.
Okay, so what is happening there? Because you're spraying it on the plant, on the leaves of the plant. So you have this on the leaf of the plants. How does that translate into the roots of that plant producing more exudates and feeding the soil microbiology?
Yeah, that's fascinating. But the leaves are actually able to absorb nutrients quite well. In some ways, the leaf is completely different design than the roots. But in the other hand, it's still the same DNA, it's still the same structure. One receives light and one not. I one time saw this picture of a tree which was growing into a cave, and in the cave, in the evening, you had some sun, and the roots developed little leaves again. So some plants can really produce on the roots suddenly leaves again. So it's very fascinating, and it shows the organ looks completely different. It has different functions, but it still can do the same, taking up nutrients.
Okay. And so the idea with it, we apply this compost tea, and it stimulates the growth of the plants, but does it have other functions, like stimulating the defenses of the plants and things like that to protect it from pests or disease? Or
yeah, the functions are quite diverse, and also our professors in our study all the time claimed it's not real science because we cannot explain from where the effects are coming. We're just guessing all the time. But of course, we have this very diverse mixture of maybe 10,000 different bacteria, different fungi, different protozoas. You have all these humic acids, which are biostimulants. You have these different amino acids, these different vitamins, enzymes. So it's kind of impossible to narrow it down where the core effect is coming and what is exactly happening. But what we see, of course, if you have a plant which is better nourished, which has a bit higher Brix reading, the sugar level in the leaf, which has more root biomass, can be more resilient against pests, against climate conditions, and in the end also can produce more yield. But you cannot narrow it down to one effect like nitrogen fertilizer, which is so simple.
Just a quick pause to tell you about the official partner of the Deep Seed podcast, and that's Soil Capital. Soil Capital is a company that accelerates the transition to regenerative agriculture by financially rewarding farmers who improve the health of their soils. They are an incredible company. I love what they're doing, and I'm super proud to be partnering with them for the Deep Seed podcast.
And so I know you showed me earlier, you have what you call a bioreactor, is that right?
Exactly. It's a bit hard to say what it is, but in the end we propagate microbiology, so it's kind of a bioreactor or compost brewing system.
Yeah, but you came up with this system yourself? You invented it? You took it from someone else?
We took some ideas which were out in the internet, get inspired and started to produce our own prototypes. And after a while, we really end up with this one brewing system out of stainless steel, which has a very easy and practical design, which we developed, yeah.
Okay, is that something that you're selling? You're replicating and selling to other farmers, or is it just for yourself?
No, I'm also selling it with EdaPro to the farmers. This system, which I showed you, is around 30 farmers in Switzerland have one. And we also have a partner in the Netherlands, which is producing by himself bigger units because the farms in the Netherlands are bigger, and is selling it since 2 years successfully. And further partners are in touch in Germany or in Spain, and yeah, we will see where this whole journey goes to.
Okay, yeah. You mentioned the waters because your recipe is, you said so.
Exactly, about the design of the brewer. What in our compost tea brewer happens is that we create a vortex. So the water is turning like you see it sometimes in a mountain river, or when you open the water in your bathing tub, it creates this vortex. So the water likes to do it. And there was an Austrian scientist, Victor Schauberger, and he explained in very more holistic or even spiritual way that the water changes its structure. And it's a very difficult topic until I met someone which is able to do the microscopic pictures of the water. You just put a little droplet onto the slide, let it dry, and then you see how the minerals form. And I gave her the different samples of water which was just aerated with bubbles, or water which was aerated with the vortex. And those pictures looked completely different. And she explained immediately, the vortex water, that is the good water. You see this very nice structure involving, and it has a lot of energy. And she explained me that also the water in the cells of a plant also is structured. And it's very narrow on being sometimes maybe a bit put into the esoteric side of science, that water can carry information, that water is changed if it's around a magnetic field or a mobile phone. But you really see it on those microscopic pictures. And we also saw that if you just treat seeds with structured water, they germinate better, they suck in the water better. And I really believe that the water in the cells is different than just normal water.
Wow. Okay. So there's actually been trials with differently structured water to see really if there's a difference in uptake and in the result on the plants.
Yeah, there are trials, and there is also some scientists, they really prove those effects. There is structured water, there's a fourth phase of water, which is not gas, liquid or frozen, which also probably is in the plant cells. And it's all published in Nature, but it really goes into deep physics, which is sometimes too hard to really understand for me and fully explain what is happening there, but it happens.
So in your bioreactor, you have this vortex movement so that your water then gets that effect while it's brewing.
Yes, exactly.
That's it. So to the water you add, you said a compost and compost food you mentioned earlier.
Exactly. We call it microbial food. So we have the compost, but the food in the compost for the microbiology is nearly used up because they used all the organic matter and build up the humic acids, the humus, which forms stable form. So what we want with our compost tea, we want the propagation of microbiology, that we have those exudates of the bacteria, the secondary metabolites. So for this, we add a plant-based food, which also has some minerals, which is very fine grounded. They can really dissolve it within 24 hours and eat it, yeah.
What do you put in that food? What is it made of?
This food is made of humic acids, which are dissolvable in water. It's a rock dust powder, which is rich in minerals, and silicon, which is very important also for the microbiology and the plants itself. And also algae powder, because it's also rich in a diverse range of minerals. And we also add different herbal powders. As we saw, we can make the whole process of producing compost tea more stable, and some alfalfa powder. It's a very fast-growing legume plant which has a very strong root network, and we get those auxins, those hormones, into the compost tea, and with it also have the better effect on the root growth, and is also rich in proteins and nitrogen, so it's a good boost for the microbiology to grow.
Okay, so all of these different ingredients ground into a powder, and then you add that to the compost tea that is turning in the vortex in the bioreactor, right? And that feeds the microbiology there, so that they produce more of these secondary metabolites. Is that right?
Yes, exactly.
And then therefore you have a better quality tea.
Yes. This is the whole principle. We basically extract the microbiology in those 24 hours and also propagate the microbiology.
So in a way, it's also a way of boosting the effect you can get from compost. So you would have a bag of compost, if you put it on the soil, well, it works a bit differently. You have to wait longer for it to decompose. It nourishes your soil in a bit of a different way than the tea. But in this case, because you feed it as well, you multiply the potential effect of that same amount of compost. Is that the idea?
Yeah, exactly. What we saw in further tests is we don't propagate the whole range of microbiology in those 24 hours. It's certain bacteria which profit a lot. But when I did my research on the internet of what are those bacteria doing, they have a very wide range of effect. They can mobilize phosphorus, they can mobilize potassium, they are root growth promoting bacteria, they are having an effect to protect the roots from diseases and so on. So the literature is very wide of these certain bacteria we propagate in the compost tea process. So what we basically can do is we have a way that the farmer can do those products by themselves on the farm, which some other companies produce in the lab and try to sell it as a plant stimulant. So we have the advantage that the farmer in the end does it by himself on the farm to produce a microbial preparation or a biostimulant, which has a great effect on the plant growth.
Why is it better to do it directly on the farm than buy it pre-made in a bottle?
most of the biostimulants, like compost tea, is 95% of water. And to ship water around, it has costs. It's also not the best for the environment. It's also when a company produces biostimulants, fill it up into the bottle and wants to sell it, there has to be a salesman going around every year, try to sell it again. There's a marketing around, the licensing, many bacteria which are plant growth promoting from the big companies. They even have a patent on it. It costs a lot of money. So in the end, those products are very expensive. They are maybe good, they work. We tested some of those products against the compost tea. Compost tea all the time had the same effect or better, and for a tenth of the price. So for the farmer, it brings really value back onto the farm when he produces by himself. And what we also realized when the farmer starts to work it also empowers him, because suddenly he is the biotechnologist which is producing it. So it really helps the farmer to get the passion for this microbiology, for the root growth, for being independent of the companies and external inputs.
Yeah, but you also have to, but the farmer also has to buy the machine in the first place, the bioreactor, right? So there's a bit of an upfront investment that you wouldn't have if you were buying a
There is a front investment, but of course, I also give a lot of courses about compost tea in our regenerative community, and I tell everyone, just go onto YouTube. There are many simple do-it-yourself options, and it depends on the type of the farmer. If he has the time, if he likes to do the trials and do some technical implementations, he can build it by himself. We have many farmers that build it by themselves, and some they say, I don't have time, I want your product, I think it's good designed, and then they buy my product.
Okay.
I don't care. My goal is to help the farmers. I buy myself a farmer, and I know that sometimes money is tight, that sometimes as a farmer you think you can do everything by yourself, and it is sometimes like this. We know a bit about electricity, we know about mechanics, we are farmers, we know about chemistry and biology and everything. That's the amazing thing of being a farmer. And we have sometimes time in winter to do such projects,
Yeah, okay. And what about the food that you feed the microbes, so that powder, that mix that you came up with? Is that also something you commercialize and sell to farmers who want to do their own?
Exactly. I sell it to the farmers like the compost, but also there some farmers, they produce their own compost. Some farmers, they have their own food source, but by the compost, as diverse our microbiology in the soil, as diverse as our customers. And we don't keep it as a closed system and say only with our product it works, because I know there are other ways to do it. Freshly produced compost on the farm can be very good. You have the microbiology on your farm, you really close the farm circle and so on. So I keep it there open. What I can guarantee, if they have our brewing system, have the compost and have the food source, that everything is adapted and worked. Like if you add too much compost and the air blower is too weak, you suddenly have not aerobic conditions, enough air, and you propagate suddenly anaerobic microorganisms which are less desired than the aerobic, which need air, and so on. So we just want to make it easy for the farmer if they don't have time to do everything by themselves. But for those farmers who like to do their own stuff, I'm also willing to help them and explain everything.
Yeah, sweet. Yeah, so obviously if they take the whole package, you know it's been worked and optimized for a good number of years. You said, 12 years?
Yeah, exactly.
You've been doing this to make sure that this is the perfect optimized recipe. This is the right machine with the right setting, with the right food, with the right compost, and that gives you a great result. But yeah, farmers are welcome to experiment and to do their own recipes and processes.
Yeah, I think I have my microscope. I can check the quality. I have all the tools to do the measurements about the dissolved air, about pH and so on. And it needs some equipment to really do your quality measurements. And some farmers really, they go into everything. And some just say, I don't want to learn to microscope. Sometimes I also like to be in the evenings with my family and I cannot sit in front of computer and learn how to microscope or something.
Yeah. Do you see this as a potential useful and powerful tool for farmers trying to transition away from conventional farming? And does this help replacing some other forms of synthetic fertilizers or things like that?
Yes, it's one little part in the whole regenerative practices, the toolbox this regenerative community has, how to work more with the nature. And what I saw, I by myself transitioned from a very intensive conventional farm to organic farm. And I tested my soils. I was by 2.5% organic matter, which is humus content. Organic matter would be even lower. And I had some compaction layers. I saw that the roots didn't grow so well. So for me, it was the question, how can I support the whole transition to a more sustainable way, to a more natural way? And there, I think compost tea really can help to fasten up the process, to stay on a good level with your yields, which you need to support the whole transition and so on,
A farmer who's in this process of maybe transitioning to a more regenerative mindset, a more regenerative system, it takes time, it takes steps. Like how does this fit in for that farmer?
For a conventional farmer, it's very hard to suddenly change his whole cropping system. When we take the example of a wheat crop, where he gonna start to use less fungicides, for example, because we know fungicides, they also kill the soil. Fungi, it's not very good. It's in a regenerative approach, not something you want to use. But how can he help now the plant to protect itself? So the compost tea really can help to have more root growth, to have a better nutrient uptake. It also helps the farmers to reduce nutrient input, because we have biology inside which also helps to dissolve potassium, dissolve phosphorus and so on. And with the lower input of fertilizer, the soil microbiology again benefits, because the fertilizers also can harm microbiology in the soil. And with it is possible to slowly go the way of being more regenerative.
Okay, so you see this as a tool in the regenerative farmer toolbox, and one of the tools to help steer the system towards towards regenerative, towards organic and things like that.
Exactly. I think in a regenerative farmers, it's all about managing its roots. A conventional farmer is all focused above ground. He wants to have healthy leaves. If they are sick, it needs fungicides. If we have sick leaves, we all the time also do the soil sample and see, is there any problem? Do I have compacted soils? How is the root structure? How many fine roots I have? And so on. So for a regenerative farmer, he really has to put his head into the soil, check also the roots. And with the compost tea, we have one tool supporting this root growth. But of course, in regenerative farming, we have many other tools like the crop rotation, the implementation of undersowings, the implementation of cover crops, which helps for a better root structure, all kind of machinery like direct sowing or just mulch sowing and so on. So as a regenerative farmer, you have a whole toolbox and you have to find for your farm, for your case, what suits me well.
Okay, yeah. We were talking earlier, you mentioned that you do leaf sap analysis and that helps you with your decision making on the farm. This is a concept that I've heard in a few podcasts recently, but I haven't really dug into. I'm completely clueless. So I'd love it if you could explain what this is, basically. What's this process? Why you do this? How does it help you on the farm?
Yeah, so as we started selling our compost tea machines and farmers started to use compost tea, we had farmers, they called us. It's a great principle. I believed in it, but I don't see any effect. So I went to those farmers and I admit I don't see any effect. So I was quite pressured. What I do now? So I started to just do my research again on the internet, and I found the podcast of John Kempf, which was for me very inspiring, that he shares all his knowledge with all those experts. And he also was talking all the time about this leaf sap analysis. And I found out then, it's a lab in the Netherlands, Nova Crop Control is doing them, and it's so close to me. So I started to do my first leaf sap analysis, and I realized it's very great because I was so focusing on the roots and then the microbiology in the soil. I did the opposite. I was only stuck in the soil and never was thinking about the plant anymore so much. So the leaf sap analysis is, for me, the plant is a mirror of the soil microbiology, of the soil chemistry. What I find there is like a blood sample of the plant itself. And it also tells you how good is the soil microbiology working with example, the silicon uptake. Is the soil maybe compacted and waterlogged? I see high aluminium content. And what is very great in the leaf sap analysis is that you have the nitrogen split into nitrates, ammonium, and total nitrogen, which also gives you a great feedback how the plant is fed. Is it fed out of the bag with conventional nitrogen fertilizers, or does the plant feed itself over the microbiology? If it's fed over the microbiology, we have low nitrate content, but still enough total nitrogen in the plant, and then we really see healthy plant growth. So it gives me a lot of information with a simple test, because the test of the leaf sap is technically much more easy because it's pure, it's clean, and soil is so diverse and so different with the pH and the minerals. So soil analysis cost much more. The leaf sap analysis are very affordable.
Practically speaking, how do you do that?
I go to the field before 9 o'clock in the morning, because then the plants start with the photosynthesis again and start to build up the sugar content. And we want to have it before, and also the plant material stays fresh when I collect them before 9 in the morning. I walk all over the field and collect young and old leaves in 2 different bags. About a bag full, it's about 100 grams of plants, which gives a good sample overview of one crop. I send them to the lab in the Netherlands, and within a week I have the results of around 15 different nutrients. And often I see that some trace elements are still missing, and those trace elements I easily can add to the compost tea and spray it onto the leaves and feed the missing trace elements. It's often, in my case, after winter, boron is washed out. I see sometimes when it gets dry, manganese is missing. Sometimes some plants like corn have a zinc deficiency, but I only need little amounts. Talk about a kilo of zinc or a quarter of a kilo of molybdenum, or even less, to help the plant work together with the microbiology and boost photosynthesis.
Yeah, okay. So it's a bit like when I go to the doctor to get a blood test, and they tell me, okay, you're missing a little bit of this, a little bit of that. You can either take some supplements or eat more broccoli, or I don't know. But like, if you do these things and you try to get those levels up in the right places, then you will be in better health and you will be functioning better. Your whole system will be functioning better. That's just basically the same idea, right? That's
the same idea, right? But what we also see is all the over-fertilization. Most of the soil samples, they think about the soil as a dead system. It's just a chemical analysis. And they try to imitate with some acids, the root exudates, and then with this they estimate how much nutrients are plant available. But now we see with the leaf sap analysis, even my soil samples say I'm very low in phosphorus, that I have very high levels of phosphorus in my leaf sap. So it tells me there are a mycorrhiza network which delivering the plant the phosphorus. So I don't need to apply phosphorus. I have many farmers, especially in potato cultivating, they applied already at the beginning of the season all the potassium. And in the leaf sap analysis we saw in the first stage of the growing, we have very high potassium levels, but very low magnesium levels because it blocks the uptake of the magnesium. But in the vegetative grow, when the plant is producing a lot of biomass, it needs a lot of magnesium to build the chlorophyll. And later in the stage, when it starts to build the tubers, we need the potassium. So with the farmers, we can now really see how much they actually have to apply and how much comes from the cover crop maybe before and when they have to apply the nutrients. So it's a different management. And often nutrient management is first get rid of the excess nutrients, which of course also the nature and the whole ecosystem profits if we don't over apply nutrients.
Obviously, and as a farmer, it helps your balance sheet, right? If you don't need to buy as much inputs because you realize that actually I have enough of this in my plants. My soil sample showed that I was lacking this, and what farmers usually do is then apply more of this. But sometimes it's just unnecessary, so you're spending money and time doing something that's not really benefiting your crop at the end of the day.
Yeah, exactly. And this is the amazing thing. The analysis helps you to save money. You don't over apply nutrients. It helps you to get a healthier crop because over application of nitrogen can really lead to a lot of fungal diseases, insect pests, and so on. And if we combine those missing trace elements with the compost tea, we also not only add microbiology, we also add the chemistry. Mm-hmm. And the amazing thing is we see that the mixture of those biostimulant and the microbiology in the compost tea helps also to take up those trace elements much better. Okay. So it's in my opinion, a very good blend of leaf fertilizer and stimulant.
Okay, yeah. Plus, I suppose then you apply both of them at the same time. It's one application rather than having to do two different operations separately.
Yes. So I anyway drive with my boom sprayer to apply the compost tea. And to add some trace elements doesn't make it much more expensive in the end. You can source them for a good price. You need so little amounts that you end up with maybe €10 extra per hectare to apply those trace elements. And with it together, we see much more consistent results. I started with this, that a customer of me didn't have the effect. So he had an apple orchard, and perennial cultures, they are harder to work with because they store the nutrients over the winter in the roots and they come up with the new growth again. So if there was over the years all the time iron and manganese missing, it gets each year worse. And with applying also those nutrients, we suddenly had the photosynthesis again working, pumping much more sugars and carbon into the root zone and start to work with the microbiology. So at the beginning with compost tea, we basically just add biology and biostimulant, but it didn't help the plant because it missed the very essential nutrients to do photosynthesis. And together we get more photosynthesis and had the biology also fed by the plant. And that's the main goal.
So if it's such a powerful tool to be doing this, to do this leaf sap analysis, it gives you so much useful information that really allows you to farm better, to spend less money, and to get better results. Why is that not something that we see almost every farmer doing and every agronomist using as a tool?
I started around 6 years ago with it, and this year I'm already nearly on my limit with helping the other farmers interpret the data. And I also talked to the lab in Nova Crop Control. They say every 3 years they move to a new building. So it really has worldwide gained a lot of attention by the farmers and it's used a lot. There is just kind of also a limit. Everyone can go out and sell this new technique. It's also, you need to understand the leaf sap analysis. It's not so easy to interpret it if you never had the results in front of you. So someone needs to explain it. And I think right now I barely see any promotion of the leaf sap analysis anywhere because everyone which is working with it tries to get all the work done they get every year, which is in my case doubling every year. So
you've been doing these kind of analysis for a number of years now, and you've been transitioning the farm here to regenerative for a number of years. So you must have seen a progression in the results that you get. Is that the case?
Yeah, I see a progression now when I take leaf-up analysis of my plants. I already see I have much more balanced nutrients uptake. I see also the trace elements going up, and I also see I have stable yields. And also an important measurement in the leaf-up analysis is the sugar content, which tells me how much photosynthesis the plants are doing.
Okay. Was that important?
Photosynthesis is taking CO2, the carbon, out of the air and producing biomass. And also a big part of this sucked in carbon gets as root exudate, as sugars, into the soil. So we bring the carbon back there where it belongs to. And this is amazing why so many regenerative systems have the good effect when we think on syntropic agriculture. It's maximizing photosynthesis and maximizing taking everything which was produced as biomass back to the soil. Or if you take a diverse permaculture system, all the time there is something growing. So we have much more photosynthesis. But when we look on conventional agriculture, you have a wheat field. It dries in July out. It's not green anymore. But then we have the longest day. And nothing is anymore capturing the sunlight and taking in those CO2, which is too much in the air and pumped to the soil. So photosynthesis is really the motor of the regeneration. And with the leaf-up analysis, I have a tool for my crops, which are now also not fully a monoculture, but the main crop which I'm growing is the wheat. And I have to support the wheat with a little trace elements to maximize the photosynthesis. Of course, when it dries, I have an undersowing over it, underneath it, which also capture a little bit of the sunlight. But it's by far not as effective as a really nice polyculture. And I've did trials in leaf-up analysis in cover crop mixture with 15-20 different plants. And what we saw there is the profile of the leaf-up analysis is perfect. So what I learned is if you have a diverse crop growing together, the nutrient uptake automatically works better.
Okay.
It's very interesting. Also, often in the cover crops, you don't see any diseases or insect pests. Those plants are very healthy.
Okay, so those analysis, they're yet another tool to demonstrate that actually regenerative farming is better. It's better for plant health, for the health of the ecosystem, of the soil, and all of that, basically. Yeah,
it really helps to see how vital is your plant. It helps in the management practices with the fertilization. And like I said in the beginning, it's not as expensive as a soil analysis. And we often recommend the farmers to do the soil analysis maybe every 4 or 5 years, especially in Switzerland. You have fields which are 1 hectare and you don't want to spend each year 150 Swiss franc on a soil analysis. It's easier to spend every year 30 Swiss franc on a leaf-up analysis and already get a feedback of all your management practice.
And do you have to do that on different fields to check if you're growing different crops? I
do it on the cash crops around 3 times a year to have the growing cycle.
Okay.
Tested,
yeah. So it's not a massive expense for you?
No, not at all. And I work with apple farmers or vegetable farmers, and they do it a bit more intense. But also their output is much higher. If they have 90% of the apple in the best quality they want to have, it's a huge gain. If it's compared to only 70% or something. Yeah.
You said that you work with a company in the Netherlands. What was the name again?
The name of the company is Nova Crop Control. And Nova Crop Control does for the whole world those leaf-up analysis.
For the whole world?
They get analysis from Australia, from South America, from everywhere.
Why not make labs doing that? If it's so popular and it's growing so fast, why not create labs everywhere, in every country or at least continent?
I also asked this question to Nova Crop Control, and the answer was they are a bit afraid that those measurements, if they set up a factory in South America, that suddenly, if they all the time do the calibration of their measurement units, is done by a different person, is done by a different protocol, that suddenly they would get slightly different values than in the Netherlands, and then you get a mess up with the data. That's one reason, because you have to think about if they measure molybdenum, it's like 0.5 parts per million. So we are in a very narrow range what we have to measure. It has to be super precise. And if this suddenly shifts 10% in the other side of the world, we suddenly get a bit different data there. And what is special on Nova Crop Control to compare to all other labs is that they take their data to define the target values. All other measurements before, they were done by trials. You had a very healthy plant compared to a plant which didn't get potassium enough, and then they said this healthy plant, that's the ideal ratio of the potassium. And Nova Crop Control said we do a different approach. We test 1,000 sample of a plant and let the algorithms decide where are the target values. And now they have millions of data sets, and they adjust the target values according to the data.
Okay, so actually it would be difficult for a competitor to start from scratch because they wouldn't have the same database and the same precision in the first place, right?
Yeah, this is as well. And I also think they are quite efficient. Like the whole process is so well designed that they really can get this good price.
And when you showed me the bioreactor earlier, you also mentioned that you can make ferments. And I said, let's talk about this later. But actually, I don't even know what a ferment is. So maybe you could start from the basic level of what is a ferment and what do you mean here?
Yeah, the ferment is kind of the opposite of the compost tea. So in the ferment, we propagate microbiology without air. In compost tea, we blow air in to have the aerobic microorganisms which need air to grow. And by the ferments, we have the anaerobic microbiology. And we use there kind of this preparation called effective microorganisms from Dr. Haigo from Japan. He invented this, and it's a collection of 3 strains of microorganisms, lactic acid bacteria, some yeast, and some photosynthetic bacteria. And he had quite a success with using it in the soil, with reduced the odor smells of the manure by the cows and so on. And we also saw that with this starter culture, you can imagine like a starter culture to make your own vinegar or a yeast to start your beer. It's all also fermentations. So we can use those starter culture, add a food source again, like in the compost tea. This time it's more sugar-based with molasses. And we let it ferment airtight with a bit warmer water, 30 degrees, 35 degrees for a week. And we have an enormous propagation of those lactic acid bacteria. The pH goes to sour. It's also when you ferment vegetables, you get this sour taste because it's of the lower pH. It's kind of similar also to sauerkraut. It's also lactic acid bacteria. So we kind of have a product which is then stable for about half a year. You can keep it when it's produced, like also when you ferment vegetables. And it's very to preserve organic matter, that it doesn't rot and get a bad smell.
So how do you use it?
Mainly on my farm, I use it to treat the manure. So the problem with the manure is in the building, when the cow poops and this poop, the shit of the cow gets together with the urine, you have these very bad reactions. That methane is produced, ammoniac, some toxic gases for the environment. And imagine when a cow shits in the nature, the shit ends on the ground above, and the urine gets filtered into the soil. So it's all the time separate. But what we did, we built a building for our animals, and now it gets together into the manure. And in the end, the manure is a good organic fertilizer, but it's in a rotting stage. It has a bad smell. It has some bad effects also on the microbiology. If you over apply it, you see the plants can get burned. The earthworms even sometimes come out of the soil because it's like they think, what the hell is this? It's not something good for us. And with the ferments, we really can lower the pH in the manure. And those lactic acid bacteria start to work. They start to digest organic material. So the manure starts to be more liquid. It somehow starts to smell less. We have less ammoniac production. And we get a fertilizer which is much healthier for the soil.
So yeah, you just mix it all together with those ferments with your manure, and that helps making it healthier basically, and better for your system, for your plants, for everything.
Yes.
Yeah.
We also see that if you collect organic material to make your compost before you start the composting process, it often happens that you get those bad smells. You have those mold, fungi growing over it, and you really feel there are nutrients going into the air. You smell it with the bad gases. And when you add there these effective microorganisms, this ferment, it helps to have the same effect, a bit like in the sauerkraut, in the fermentation process. We add those lactic acid bacteria and we preserve the nutrients before they are composted.
Okay.
And everywhere where you have those bad smells, have a bit over-application of nutrients, it helps. And we also saw in regenerative farming practices different uses. Sometimes you have compacted soils, so you work with a subsoiler. You go maybe to 30 centimeter deep, only lift a little the soil to get some little scratches into the soil that the roots can grow into it. So we suddenly bring in an aerobic soil air, and suddenly with the air, nutrients could be released which are not taken up yet by the plant. So if we spray there also the ferments into those deeper layers, we can control the environment. Same as when you take the mulcher and work in the cover crops. A lot of nutrients are suddenly released because you make this very fine cutted plant material. And also there, if you have a lot of dense cover crops, it can happen that this just gets very bad and starts to rot, and you have bad smells again. And if you have those bad smells, you won't have a good root growth. They don't like those rotting stages. They want to have those preserved nutrients like in a sauerkraut.
Being a regenerative farmer is like being a scientist in many ways, right? You have to understand a lot of different concepts, a lot of complicated scientific concepts if you really want to do things well.
Yeah, and I'm also working as a teacher in Regenerative Switzerland, and it's really when we do our courses, they go 1 year, 4 times 1 day on a farm, and around 8 times in the evening with online courses. And that's our feedback, what we get. Like, I'm overwhelmed with all those informations. But what we also realized is you cannot just simply change one thing on the farm and everything works. Like if you suddenly change from tillage to non-tillage, but you don't bring your nutrients into the balance, you don't help the root growth, you don't correct the fertilizing management, you maybe fail. And if you start then again, we don't know. So I think that's the hardest part in the whole transition, to really present all those informations that the farmers get everything how to work with it. Yeah. And I admit it's complicated. That's why we are there to help. That's why there are also companies produce those products finished. You don't have to do it by yourself. But I see in my farm, the transition, it costs money, and everything, especially for me as a small farmer, I can do by myself, helps me to save money. And this helps me to go faster in the transition process.
Yeah. It would make sense to have more also agronomists there to help farmers, who can be also the person who spends time learning all of that scientific information and helps the farmer make the right decisions, rather than the farmer themselves having to do all of that by themselves, being very busy already on the fields and stuff.
It definitely would help. I think most of the time the problem is that the advisors which go on the farms, they sell products. That's how they are paid. And of course, they have different interests. So we really need more neutral advisors which support the farmers. But we also have to teach the farmers to learn to observe. This is very important. They need to dig out the roots, look at the soil, that I see now I did this management practice, this happened. Because each farm is individual, and as an advisor, it's very hard. You get to the farm and you have to help immediately, but you don't get the whole picture of the farm immediately. So the best is if the farmers really get this eye for those details and see, now I have whittled plants. And then I think also the passion comes because you start to work with nature again.
Yeah. You give courses, you give classes. Is there any resource available online that farmers can find to learn more about this?
I mean, most of it is really on the platform regenerative.ch, which I just help as an expert. You find some YouTube videos, but I'm not really those specialized in social media content, make a lot of YouTube videos and everything.
Other resources you would recommend, podcasts, books?
Yeah, of course. I already mentioned John Kemp as a great source of information. Also, I'm a bit on the path like Graham said in Australia. He has the same principle. I liked, of course, Elaine Ingham with the whole soil food web. I read right now the book Super Low Cost Natural Farming, Korean Natural Farming. It's a whole new setup of like 20 different bioferments. And I think you really have to find a bit of Facebook groups you like. I'm in a Facebook group which is called Bioferments and has very good content all the time about how to design your own fertilizers, leaf fertilizers, how you deal with different problems. Yeah.
Okay. Yeah. Thank you so much for your time, for your expertise. I really appreciate it. Thank you.
Yeah, thank you for doing this interview that the farmers have the chance to also listen all my ideas I implement on the farm. Yeah.